In this video on the Certified Q&A, let's tackle another question for the Google Cloud Platform Associate Cloud Engineer. It's very important to the process of understanding Google Cloud and passing the certification exam that you go through the question and attempt answering it yourself first. So pause the video, work through the question. We'll catch up in just a little while and I'll show you how I do it. In this project scenario, you have an application server running on Compute Engine in the Belgium region. It is currently in the zone Europe West 1D. Your business realizes that there is a lot of traffic coming in from the London, England region and believes that we can provide high availability by replicating the server to the London region. We choose the zone Europe West 2C to replicate the server into. The requirement for your project team now is to have this done in the fewest steps possible. So in approaching this project requirement, the two things we need to consider are that we need to replicate the server and we have to do it in the fewest steps possible. Before we do that, let's find out what do we mean by Europe West 1D and Europe West 2C. Google's infrastructure is spread all across the world. In many places across the world, there are data centers in what are called regions. Each region is going to be separate from any other region by a minimum of 100 miles. This means that even if a region is affected by some local geographic problem, like say floods or an earthquake or a political situation, the other regions still have a very, very high chance of being available. Almost certainly, these regions are going to be available even if one or the other goes down. Now, we do often talk about, what if it goes down? But it has rarely ever happened. I don't think it has happened at all. There have been zones that have gone down, but probably not entire regions. Even then, even for the rare, very, very rare occasion that it happens, we do not want to have any lost traffic, any lost business. Therefore, it's a good idea to have your data and your services replicated in different regions to provide high availability. The other reason to have your applications replicated is so that users who are in a local region can access your application with very low latency. These regions are spread across the world. The ones with a filled blue marker indicate regions that are currently available, and the number within that indicates the number of zones in that region. The ones with the white fill marker are the ones that are planned for future. Within these regions, there are multiple zones, typically 3 or sometimes 4. And within the zone is all the hardware and the chipsets and the hard disks that are all interconnected with a very fast Jupyter network. The way the regions and zones are named are that first you start off with the region. And the regions are typically the continent, but then US has its own region. So the regions would be like US, Europe, Asia. Each of these regions are located somewhere close to a city. So for example, there could be two, there are multiple of course in the US, but we'll pick 2 of them, one in Iowa in the US and Oregon in the US. Depending on the geographic direction they are in within that region, they usually have a name like East, West, North, South, or Central. Since there could be multiple regions, say even along the West Coast, you also have a number to them. So you could be, say the one in Oregon is region number 1 on the West Coast. And the one in California might be region number 2, again on the US West Coast. And then within these regions are the zones, typically named ABC onwards, but not all of them might be there. So the way you name a region is you have the region plus the geographic direction like central west or east or northeast, any of these, attached with a number. The zones within them additionally have an alphabet depicting the zone. So the complete definition of a zone would go like US Central 1A, US Central 1B. In comparing that to the project requirement we have, the two zones are Europe West 1D and Europe West 2C. So clearly now, since they are in Europe West 1 and Europe West 2, these are in two different regions. Of course, in across regions, they're also across different zones, and there is no particular connection between the zone numbers. So a Europe West 1A and Europe West 2A have no connection at all. When I mean no connection at all, I don't mean a network connection. I don't mean they have any particular logical connection. They're not grouped in the same area, and they do not have anything specific that connects a Europe West 1A to a Europe West 2A separately as a Europe West 1B to a Europe West 2B. So the zones are isolated, but they're very close to each other in the region. So if you want to have fast computation, you want to carry that out within a region among the zones. Whereas if you want to have high availability and also to serve an international audience, ideally you want to replicate them across regions. In this particular case, this is what we are doing. Now, we reach out to our project team and they have done some research. And we first asked Bob, what do you think? How can we get this done? So Bob has done some research and finds out that we could potentially create a snapshot of the disk. Then from the original zone, create a disk from the snapshot, copy the disk over to the other region, and create a new VM based on that disk. It seems fairly straightforward. There are a few steps involved, but first let's see if this is possible at all. So we go into the console, we've created a disk, and we can see the disk is currently in US Central 1A. We can also list all the disks by running the gcloud command gcloud compute disks list. In step 2, we try to move this from this zone in the current region US Central 1 to another zone US Central 1B. So we're just testing out whether it's possible to even move a disk between zones in a region. When we do that, the command does an error out and instead it actually succeeds. In the intermediate step, in step 3 though, we can see that a snapshot is being created from the disk in the background. Then based on the snapshot, a new disk is created in the new zone and eventually the snapshot is deleted. So that part is taken care of for you automatically. How about moving disks across regions? Is it possible to do that? In this particular case, we start off with disk 1, which is now in US Central 1B in step 1. In step 2, we run the command gcloud compute disk move disk 1, which is a name, which is currently in the zone US Central 1B, and we specify the destination zone as US West 1A. We can see in step 3 that this completes without an issue. So yes, Bob's suggestion will work. The only question now is whether it is the fewest steps possible. We don't know that yet without considering the other options. So we're going to keep this aside for a while knowing that it works. We check with Charlie, hey, what have you found out about how we can resolve this? Charlie has a thought that we could probably use gcloud directly to copy the disk to Europe West 2C. This seems great if it would work. Unfortunately, we find out that this is not possible based on the documentation. gcloud compute disk does not have an option to directly copy a disk. So we are having to eliminate this option. Over to Dave now, who suggests that we run the command gcloud compute instance move and provide the parameter which specifies the destination zone. This again seems fairly straightforward. However, is it possible? Let's try it out. So we move into the console and we run the command gcloud compute instances move and try to move the instance, say, from the current zone, which is US Central 1A, to another zone in the same region itself, US Central 1B. When we check that, we realize that we can move a compute instance from a zone in a region to another zone in the same region. We next check whether it is possible to move the compute instance to another region. In this case, our destination region is US West 1 and Zone B within that. And it errors out saying that the instances belonging to subnetworks cannot be moved interregionally. So it is not possible to move compute instances between regions using the gcloud compute instances move command. Now, I do not fully understand what this error means because it says instances belonging to subnetworks cannot be moved interregionally. I do not understand why they mention subnetworks because all the instances that we create are going to be part of a subnetwork. In any case, we move on with the understanding that these compute instances cannot be moved interregionally. So we have eliminated this option, but we also can notice something in the option which suggests that we use gcloud compute instances move. But looking at the question, we do not want to move the instance. We want to replicate the server, which means there should be a copy. So even if this option did work, it was not going to be the right option for us because it does not suit the requirement of replicating the server. Now let's check with Alice what she has done. Alice has tried out to snapshot the disk in the source zone. Then over in the destination zone, she's created a disk from the snapshot and a new VM with that disk. Is this workable? She has tried it out and it seems it is possible. So from the instance, we can create a snapshot. And in this case, when creating a snapshot, we say the source disk is instance 1. After we've done that in step 2, we can see in the snapshots list that there is a snapshot created as shown in step 3. From that point on, Alice now clicks on the snapshot in step 4, and in step 5, there is an option to create an instance based on the snapshot. In step 6, we choose the region and the zone where we want to move or where we want this new instance to be created. And in step 7, we can see that the VM has been created. So Alice's suggestion works. In comparing with option B though, which was almost very similar, we can see that this answer from Alice narrowly wins against the option provided by Bob. There's only one step of copying the disk which is extra compared to what Alice has suggested. My memory on this is that some of these features about copying disks and moving instances have been recently added and it was not there quite a while back. So these questions were created a little earlier, and if I remember right, this was a way more straightforward option at that point. Today, it's very small. The winning option is just barely separated from one of the others. In any case, I think this is still the right option for this question. What are the key learnings from this project scenario that we solutioned? In the exam, sometimes the choices might be very close together. I have been often very confused with two options that were so close, and at one point I was like, or not at one point, at many points during the exam, I was like, you know what, between this, it's a toss. I'm just going to go with one of them. But keep looking back at the requirements, look out for specific scenarios, specific words, and try to logically figure out which one might be better. Figuring out and knowing Google recommended practices are very important. Often, like in this case, yes, there are multiple ways to get the same task done, but which would be the recommended way? You can often find this in the best practices for some of the product documentation. When working with regions and zones, know the nomenclature. How are they named? You do not need to know where these zones and regions are. You don't need to know the geography of where it is laid out. There are some resources that are zonal and some that are regional and some that are global also. Not all of the resources can be moved between zones or between regions. When working with the question, also watch out for the source and destination zones. It might be just a number like in this case, Europe West 1, Europe West 2. Identify what they're trying to ask of you. Is this in the same region or is it in a different region based on the nomenclature? I would also recommend that you be very comfortable with G-Cloud compute operations, especially working with instances, disks, images, snapshots. The Quick Labs exercises can be very useful for this. I'll leave it a few references on regions and zones, about how they name them, where they are, what are the kinds of resources and whether they are global, regional, or zonal, and some of the commands using G-Cloud, G-Cloud Compute Disk, G-Cloud Compute Instances, and how to move them between zones. All right, now it's time for you to like, share, comment, and subscribe. Go ahead, do that right now, because there's loads of great content coming up for learning Google Cloud and preparing for the certifications.